Hey guys, today we are talking about the intermediate value theorem. So question 1 says, does the function negative 3x squared plus 3 have a 0 on negative 2 to 0, and how can we mathematically prove this? So in algebra, what you would have done is set this equal to 0, go backwards and solve for x, and then check to see if that x is in between our interval of negative 2 to 0. For calculus, we're going to use something called the intermediate value theorem. So what I'm going to do is I'm going to find f of negative 2, and I'm going to find f of 0. So if I'm looking at negative 2, that's negative 3 times negative 2 squared plus 3, or negative 3 times 4 plus 3, which should end up giving us a negative 9. Then when I plug in 0, that's negative 3 times 0 squared plus 3, which is going to give me 3. So I can see that at negative 2, I have a negative number, and at 0, I have a positive number. So that means that at some point, if we're looking at our graph, at negative 2 right here, I've got a negative number. 0's got a positive number. So at some point in this interval, we had to have crossed the x-axis. So we have to have a 0 somewhere because we had to have crossed there. So what we're going to say is, since the equation goes from a negative value at x equals negative 2 to a positive value at x equals 0, there must be some x value in between where f of x equals 0. Okay, so that's kind of the main idea of our intermediate value theorem. When we're looking at number 2, we have a table right here, and it says the table below gives some values for the function f of x. Does this function have a 0 on negative 2 to 0? And how can we mathematically prove this? So for this one, I'm going to kind of make a little graph over here. And so at negative 2, I'm up here at 1, 2, 3, 4, 5. At negative 1, I'm at 2. And then at negative 0.5, I'm at negative 1, 2, 3, 4. So when I'm looking at this graph, my f of x function, I don't really know what it is here. So it could be some function that's continuous, but it also could be some function that, let's say it's a straight line right here that goes through my 2 points, but then this line picks up over here. It could be a piecewise function. So I cannot mathematically prove that it has to cross the x-axis between negative 2 and 0, because I don't know if this function is continuous or not. So I'm going to say that the function is not necessarily continuous, so we cannot prove that it has a 0 on that interval. So we cannot prove that it has a 0 on our interval negative 2 to 0. Now, if we look at number 3 right here, it's the exact same thing, except for this does tell us that it's a continuous function. So that means that I have this exact same graph, but I know that it has to be connected. So I can say yes, because at negative 2 right here, I've got a positive value, and at negative 0.5, I've got a negative value. So somewhere between those two, it has to cross my x-axis. Even at negative 1, I've got a positive value. So somewhere in between these two, it has to cross the x-axis. So I could even make the interval smaller. So the function is continuous. Oh, getting ahead of myself. Continuous Okay, let's try that again. There we go. So it is continuous and goes from a positive value at x equals -1 to a negative value at x equals -0.5. So it must cross the x-axis in between those two values. So we've kind of talked about the intermediate value theorem. Let me give you an actual definition for what the intermediate value theorem is. So this says that if f is continuous on some interval a to b and k is any number between f of a and f of b, then there is at least one number c in our interval that f of c is equal to that k. So we've talked about k being 0. It doesn't necessarily have to be 0. It could be some other number. So let's look at number 4 right here. It says use the intermediate value theorem to show that f of x has a 0 on 0 to 1. So the first thing that we need to show is that this is continuous, which this is a normal polynomial, so this is continuous. So I'm going to say since f of x is continuous, on my interval from 0 to 1, and this is where I need to show that we've got a 0 in between our values of 0 and 1 right here with some x value in between those two. So I'm going to figure out what f of 0 is, and I'm going to figure out what f of 1 is. So f of 0 is 0 cubed plus 2 times 0 minus 1, so that gives me a -1. That's a negative number. And then I've got 1 cubed plus 2 times 1 minus 1. So 1 plus 2 minus 1, so 2, which is a positive number. So I can say that f of 0 is less than 0, which is less than f of 1. Because f of 0 is negative and f of 1 is positive. So since it's continuous and we've established that we have one value that's negative on our endpoint and one value that's positive on our endpoint, we can say that there is a value x equals c. And let's actually specify that x equals c is in our interval. So a value x equals c on our interval 0 to 1, such that f of c equals 0 by the intermediate value theorem. Or sometimes it's just called IVT, the intermediate value theorem. All right, let's look at another one. So 5 says, use the intermediate value theorem to show that there exists a solution to cosine of x is equal to x on the interval 0 to pi over 2. So what I'm going to do here is I'm going to rewrite this as the cosine of x minus x equals 0. So I'm trying to show that there is some solution where the cosine of x minus x equals 0 on my interval 0 to 2 pi. So first, you need to say that this is continuous, which this one is a continuous function. So I'm going to say, since cosine of x minus x equals 0 is continuous, on our interval 0 to pi over 2, and now I need to check what is the cosine of x minus x when x is 0 and when x is pi over 2. So I'm going to look at the cosine of 0 minus 0, and I'm going to look at the cosine of pi over 2 minus pi over 2. Well, our cosine of 0 is 1, minus 0 gives me 1. And then the cosine of pi over 2 is 0 minus pi over 2 gives me a negative pi over 2. So I'm going to say, and the cosine of pi over 2 minus pi over 2 is less than 0, which is less than the cosine of 0 minus 0. There is a value x equal to c on my interval 0 to pi over 2 such that the cosine of c minus c is equal to 0 by our intermediate value theorem. So all I'm saying is, since it's continuous and this one is negative and this one is positive, there has to be somewhere where it crosses our x-axis in between those 2 points. All right, let's look at 6. So verify that the intermediate value theorem applies to the interval and find the value of c guaranteed by the theorem. So this time we're looking for 6 instead of 0. So we're going to follow the whole procedure that we did for the last two. We're going to do it all exactly the same, except for this time, instead of it equaling 0, we're looking for where it equals 6. So this right here is a rational function. So it's not continuous at x equals 1, but that's not in our interval. So it is continuous on our interval. So I can go ahead and say that f of x is continuous on my interval 5/2 to 4. And now I need to find what f of 5/2 is and what f of 4 is. So when I plug 5/2 in, I'm going to have 5/2 squared plus 5/2 over 5/2 minus 1. And that ends up getting me a 35 over 6. And then when I plug in 4, I'm going to have 4 squared plus 4 over 4 minus 1, which ends up giving me 20 over 3, or to rewrite it so we have the same denominator, that's going to be 40 over 6. And remember that 6 is 36 over 6, so that's in between these two. I've got 35 and 40, 36 falls in between there. So I can say that f of 5/2 is less than 6, which is less than my f of 4. So f is continuous on this interval, and f of 5/2 is less than 6, which is less than 4. So there is a value x equal to c. Let me rewrite that so you can actually read it. X equal to c such that f of c is equal to 6 by our intermediate value theorem. And so now the last thing that we need to do is actually find what that is. So it says verify that the intermediate value theorem applies and find that value. So I'm going to say that x squared plus x over x minus 1 is equal to 6. So that means that x squared plus x is equal to 6 times x minus 1, or x squared plus x is equal to 6x minus 6. I'm going to move everything on the same side, so that's going to get me to x squared minus 5x plus 6 is equal to 0. When I factor that, I'm going to end up with x minus 2 times x minus 3 is equal to 0. So x is equal to 2 and x is equal to 3. But remember, we're looking at our interval from 5/2 to 4. So The only one that actually falls on our interval is 3. 2 is below our interval because 5/2 is greater than 2. So my answer here would be that x equals 3, or since we're looking for the value c, I would say that c equals 3. All right, let's look at 7. The functions f and g are continuous, and g is strictly increasing. The table above gives values of functions at selected values of x. The function h of x is equal to f of g of x minus 8. Explain why there must be a value for s for 1 less than s less than 3 such that h of s is equal to -5. So my interval is 1 to 3, and the value that I'm looking for is -5. So since f and g are both continuous, that means that h is also going to be continuous. So I can say that h of x is continuous. And I really cannot spell today. I'm sorry, guys. Continuous on my interval 1 to 3. And now I need to find what h of 1 is and what h of 3 is. So h of 1 is going to give me f of g of 1 minus 8. So f of, well, g of 1 is 2, so f of 2 minus 8. F of 2 is 9, so 9 minus 8, which gives me 1. And now I'm going to find h of 3, so I'm looking for f of g of 3 minus 8. So coming back to my table, I can see that g of 3 is 4, so f of 4 minus 8, and f of 4 is -1, so -1 minus 8 is going to give me a -9. So I've got a positive number here, a negative number here. So that would work if we're looking for 0, but we also know that our value is -5 right here. And I know that -5 falls in between 1 and -9. So we're good. So I'm going to say that h of 3, because that one is our -9, is less than -5, which is less than h of 1. So there is a value x equals s, because remember they're looking for h of s, on my interval 1 to 3, such that h of s is equal to -5 by the intermediate value theorem. So there's number 7. And we've got one more that we're going to look at, number 8. So this one actually is an old AP test question. So this is kind of an idea of what it would look like on an AP test. So water is pumped into a tank at a rate modeled by W of t liters per hour for 0 is less than or equal to t is less than or equal to 8, where t is measured in hours. Water is removed from the tank at the rate modeled by R of t, where R is differentiable and decreasing on 0 less than or equal to t less than or equal to 8. And selected values of R of t are shown in the table. At time t equals 0, there are 50,000 liters of water in the tank. So on our interval, is there a time t when the rate at which water is pumped into the tank is the same as the rate at which water is removed from the tank? Explain why or why not. So what I'm looking for is where W of t is equal to R of t. Or I could write that as W of t minus R of t is equal to 0. So I'm looking for that on my interval 0 to 8. And for this one, you are going to need a calculator because we do have an E here that we're going to have to work with. So I know that my W of t equation is continuous because it's got our E from 0 to 8. And then it tells me that my R is differentiable, which means that it is continuous. So I know that they're both continuous. So I can say that W of t and R of t are both continuous. And then the next thing that I need to figure out is what is W of 0 minus R of 0, and what is W of 8. minus r of 8. So you can use your calculator to figure out what w of 0 is and what w of 8 is. So I'm looking at 2,000 e to the negative 0 squared over 20. And I'm looking at 2,000 e to the negative 8 squared over 20. And then my r values can be found in our table. We've got a 0 and our 8. So for w of 0, should end up with 2,000. And for w of 8, we should end up with 81.524. So for my first one, I'm looking at 2,000 minus 1,340. And for my second one, I'm looking at 81.524 minus 700. So for my first one, I'm going to end up with 660. And for my second one, I'm going to end up with a negative 618.4756. So I did all of this using my calculator. I know I'm going through it quickly right now. I don't want this video to be too long. You can pause it and go through and double check all of that work using your calculator. So this one's negative and this one is positive, so that means that 0 is going to be in between them. So I'm going to say that they are both continuous on my interval 0 to 8. And w of 8 minus r of 8 is less than 0, which is less than w of 0 minus r of 0. Remember that you always put that negative one first. So there is a value x is equal to c on my interval 0 to 8, such that w of c minus r of c is equal to 0 by my intermediate value theorem. All right, that is all for this video. Homework 1.7 is going to be due next class period, and you need to start working on your Unit 1 review. Have a good day.